Algebra 1, Chapter 2, Test Review video. We will be solving and graphing on the number line. So consider what we have. M divided by 5 is greater than negative 5. We are going to multiply both sides by 5 in order to get rid of the fraction. So M is greater than negative 25. Let's put this on the number line. Remember, make your number line fit the problem. So negative 25 in the middle, negative 26, negative 24. Open on negative 25 and shade to the right. Why? Because our answers are greater than negative 25. Next, negative 2/3 times m is greater than or equal to negative 8. Let's do it again. Let's get rid of the fraction by multiplying both sides by 3. The 3's cancel. Now we have negative 2m is greater than or equal to negative 24. Next, let's divide by negative 2 because that is going to get the m by itself. That is also the glitch. But bam, we're dividing by a negative. So we are going to have to flip that inequality sign, which gives us m is less than or equal to 12. So on the number line, closed on the 12 because it is inclusive, and our answers are less than. Shade to the left. Number 3, we need to use the distributive property here. Distribute the fraction, distribute the negative 4. Negative 1/3 times 6x, that's the same as 6 divided by 3, that's negative 2x. Negative 1/3 times negative 15 is plus 5. Less than, take the negative 4 through. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. So from there, we want to bring our variable over to the left, and we want our integers on the right. I'm going to start with the 5 minus 5 minus 5. Negative 2x is less than negative 4x minus 13. Both of those numbers are negative. Add the numbers and keep the sign. Now let's add 4x to both sides because we want our variables on the left. X's cancel here. Negative 2x plus 4x is 2x less than negative 13. Next, divide by 2, which gives us x is less than negative 13 over 2. And if you would like to change that to a mixed number, that's fine. 13 divided by 2 is 6 1/2. So on the number line, put that negative 6 1/2 in the middle. We'll put negative 7 here and negative 6 here. Open on negative 6 1/2. Our answers are less than negative 6 1/2. So we will shade to the left. So here we've got a compound inequality. This is an OR. So 3 minus 2x is less than 3. We're going to start by subtracting 3 from both sides, and we get negative 2x is less than 3. Divide, or whoop, excuse me, 3 minus 3 is 0. So we'll be dividing by a negative 2, which of course, when we divide by a negative, it's the glitch. We're going to flip the sign here. So we get x is greater than 0. To the other side, divide by 4, divide by 4, x is less than negative 4. So our answers are going to be bigger than 0 or less than negative 4. So this is going to create a disjunction. There's negative 4, there's 0. Open on the negative 4, shade to the left. Open on the 0, shade to the right. Our answers exist in one interval or the other. It's a compound inequality. This is another compound inequality, and this is a greater than sign for this absolute value inequality. And we need to do step 1, which is, of course, to isolate the absolute value. So if we want to isolate the absolute value, we need to multiply both sides by 3 because we need to undo the divided by 3. So the 3's cancel and we get the absolute value of 2t minus 4 is greater than or equal to 30. That is step 1. Step 2 is to set up the two cases. So we end up with 2t minus 4 is greater than or equal to positive 30. And remember, this is a greater sign, so this will be an or situation. Or 2t minus 4 is less than or equal to negative 30. And the reason is if we want our absolute value to be greater than or equal to 30, then we have to go in opposite directions on the number line. Bigger than positive 30 or less than or equal to negative 30. So note what has changed in the right-hand second case. Step 3, of course, is to solve. So we are going to solve here. So plus 4, 2t is greater than 34. Divide by 2, t is greater than or equal to 17. Or plus 4, 2t is less than or equal to negative 30 plus 4 is negative 26. And it's perfectly fine for us to have a negative number on the top. Divide by 2, t is less than or equal to negative 13. Where are our answers? Our answers are greater than 17 or less than or equal to negative 13. So we're going in opposite directions again on the number line. So closed on both sides and nothing in the middle. That's our solution set. Number 6, another absolute value. And remember, our goal in step 1 is to get the absolute value by itself. That's what we have to isolate right there. So we're going to start by subtracting 10 from both sides. Negative 10 plus negative 10 is negative 20. We're still not done yet because we have to undo the times negative 4. So divide by negative 4 on both sides, which of course is the glitch. We're dividing by a negative, flip that sign. Negative 20 divided by negative 4 is 5. That's what it takes to do step 1. Next, we are going to set up two cases. X minus 5 is greater than 5. And we have another greater situation. X minus 5 is less than negative 5. So plus 5, x is greater than 10. Or plus 5, x is less than 0. Our answers are bigger than 10 or less than 0. There's 0, there's 10. Open, shade to the left, open, shade to the right. Let's do one more because I don't have an and in my stack, and I thought I did, so let me make up one. The absolute value of 1/3 x minus 3 is less than or equal to 5. So we don't need to do step 1 here. It's already done. Let's set up our two cases quickly. 1/3 x minus 3 is less than 5, and 1/3 x minus 3 is greater than or equal to negative 5. Remember, on an and situation, our number line solution set should overlap and meet in the middle. plus 3, plus 3. 1/3 x is less than or equal to 8. I want to undo a times 1/3, so I am going to multiply both sides by 3 and get x is less than or equal to 24. Same thing on the other side, plus 3, plus 3. 1/3 x is greater than or equal to -2. Again, let's multiply both sides by 3 to get rid of that fraction. 1/3 of 3 is 1, so x is greater than or equal to -6. So our answers are greater than or equal to -6 and less than or equal to 24. So on the number line, there's -6, there's 24. Both are closed because of the or equal to. Our answers are smaller than 24 and greater than or equal to -6.